Hello, everyone. Wherever you're joining us from today, maybe good morning, good afternoon, good evening. We have a crowd here from over 50 different countries. So welcome to you all. Thank you so much for joining us. My name is Erin. I'm a startups program manager here at Google Cloud. And I am so excited to be here with you all today as the host of the session. As you all probably and hopefully know, today's session is the agentic revolution. So why now is the time to build intelligent agents? In just a few minutes, I'll be bringing John on stage. He will help you explore the agentic shift. So in this session, you will discover why agents are revolutionizing all industries, learn about their different core capabilities, and why now is the time for startups to start building them. So before I introduce John and you get into the content today, I do just have a few housekeeping items to run through, a few reminders. So bear with me and then we'll get to the good stuff shortly. So just to give you a sense of where we are in the startup school curriculum, I did want to point out, if you haven't heard, we have week 0 session available on demand already. So this was available last week. Hopefully you all heard about that and you know before you go and reminder emails. But if you haven't, here is your reminder. We have an amazing week 0 session about building your first AI agents on Google Cloud. It's kind of the essential critical starter session or pack for startups and developers. So go check that out. It's under an hour, super helpful. And yeah, take a look. So as you all know, just discussed, we're in week 1. We're so excited you're all here. We'll go through John's session in just a few minutes. On Thursday, we have our second session, which is architecting intelligent agents. So join us then. Next week, we'll move into week 2. We'll go through models and the agent engine, how to choose and use the right AI power for your agents, and then unlocking agent potential. The team will get into different tooling and ADK, or the Agent Development Kit. Week 3, we've got some really exciting stuff as well. We'll walk you through how to build your first agent, so getting hands-on with the ADK. Datadog, super excited to announce they are a program partner for this quarter. They will talk to you about observing LLM applications using Datadog, of course. And then we'll close off with deploying your agents, so how to host, scale your agents, and then some best practices and insights. So definitely check out the sessions that are helpful for you. Hopefully they all are. We've really created and curated them to walk you through the end-to-end development and deployment of agents. All right. For anyone who is new to Startup School, I just wanted to quickly run through the program structure. So all of you who are here today, obviously joining us for our live sessions, and we have live sessions each Tuesday and Thursday at the same time each week. So join us, please. All of the sessions do become available on demand about an hour or so after the session is live. So if you miss something, if you want to rewatch something, you can go to our website and watch the sessions back for a refresh or anything like that. In addition, you all likely know that we want you to practice what you learn in class. And so we recommend using Cloud Skills Boost Labs and notebooks. We have a recommended list of those in the link you see on your screen. We'll send this out via email. We'll talk about this again at the end of the session. So don't worry if you don't get this link right now, but we will provide basically all the recommended labs and notebooks for you to practice what our amazing speakers go through in class. And just a note there, you are able to obtain skills badges for completion of certain labs and courses via Cloud Skills Boost. All right, let's quickly talk about Cloud Skills Boost. I know this is always a hot topic. So again, you will be able to access the recommended labs free of charge, but in order to do that, you do need to fuel your account with credits on the platform, on the Cloud Skills Boost platform. So all of the information on this slide was provided in a reminder email or confirmation email that everyone received who registered. So if you haven't seen that email, please double check your spam or junk folders for emails coming from googlecloud@google.com. We haven't heard of any cases where the email wasn't there, but if for some reason, you can let us know. So anyways, we have instructions on how to activate your Cloud Skills Boost account. And so again, that QR code that you see on the screen right here, or that link will take you to those instructions to redeem your credits. So once you get to that link, you fill in your details, verify your email, and you can basically finish the first kind of course, which is about 5 to 6 minutes. And then the credits will be added to your account. If you do have any questions, if you have any issues, you can email startupschool-external@google.com and our team will be happy to help you. But take a look at those instructions first and hopefully everything works smoothly for you all. All right, last housekeeping items, I promise, before jumping into today's class. So these will help you make the most of your time at Startup School. On your screen, you can see a chat function on the right-hand side. You can use this to chat with different attendees. We have Google experts on hand as well. There's also a Q&A panel at the bottom. This is really where all of the Google AI experts will be on hand to answer your questions that come up throughout the class. Please ask your questions in either of those spaces, but the Q&A panel is likely a little bit easier just because you're able to upvote questions if you see something that resonates with you that you want answered. We do save the last 10 minutes of class for live Q&A with your instructor. We select the most commonly asked questions and those also relating directly to the content. So again, you can upvote any questions in the Q&A panel so that we can try to prioritize those and then use the chat space to converse with other participants and attendees. Mentioned this earlier, but we are recording each class. You'll be able to watch all of the sessions back on demand afterwards. You can access the recordings via the main program page. We will also send them out in our weekly recap emails, so several places to find those. As a reminder, we won't be sharing slides, but we will share the links to the labs that we cover in class, both in the chat and the Q&A panel and in our weekly emails. And then you can also find the list on the resources tab on our webpage. So plenty of spots to find the same thing, which is hopefully helpful. Last but not least, this is a hands-on training series. Most classes do cover labs and demos. All of the labs are available on the Cloud Skills Boost platform or on the Google Cloud GitHub repository. Again, we'll share all those links with you to access both of these resources. So we really strongly recommend using the time during the live session to watch any instructor going through the lab and then completing it on your own after the session. One final reminder, the credits that we provide will last you the full 3 weeks of the program. So you have plenty of time to do them on your own. So again, don't feel the need to do them during the live session. Okay, that is it for me. Appreciate you all bearing with me. I am so excited and delighted to invite John, today's speaker, to our virtual stage to lead class. So welcome, John. I will see everyone a little bit later for the Q&A section. Enjoy.
Thank you, Erin. I'm so pleased that Erin was the person to bring me on today, because you may not know, Erin is the genius behind Startup School. So if it was not for Erin, none of this would happen. And she works tirelessly, and it is a ton of effort to bring this all to you. And so we're super pleased that you're here and going to spend some of your valuable time with us. And I was really pleased to see that it was Erin. I thought I was going to have to introduce myself, and I had this big plan to wear 2 shirts and duck and then come back with a different shirt. That it wasn't going to work. So Erin helped. My name is John Alioto. I am a startup evangelist here at Google Cloud, and we're going to talk about agents today. And I'm thrilled to bring this topic to you. So, let's talk about what's going on with agents. And I know this is a shock. When I was coming up with content for this talk, and this series, I thought, hey, let's do a really niche topic in AI that nobody's really talking about. And I kind of came up with this idea on my own. And so I know it's kind of shocking, but I think as we go through this set of weeks in the courses, you'll see that this is really an important thing to talk about. Of course, I'm kidding. Everybody is talking about agents. And when I put this content together, I wanted to help understand at least my perspective, why startups should care. I'm a startup founder. I'm a startup CTO. I'm a startup CEO. Everybody in AI is talking about agents. Why? Right? Is it hype? Is it just what's on X? What is causing this agent revolution? And so that is the idea of my talk today. And hopefully by the end, you will see at least what my thinking on that is. So the best place to start is with some definitions, because I see these conversations about agents between people, and I see them talking right past one another. Sometimes someone will have an idea of what an agent is in their mind, and the person they're speaking with has an idea of what an agent is in their mind, and they're speaking to one another and saying agent, 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 and they are just absolutely missing what the other is saying. So I wanted to start with some definitions, at least from my take and how I think about agents and how I plan to discuss them through the rest of this talk. On the left-hand side, you have your conventional agents, right? They are single purpose. Imagine a customer service agent, right? It is AI powered. It generally has linear interactions. So what I mean by that is it's pretty easy to define the conversation between, say, your customer and the agent. It's a customer service agent. It helps your customer get their order status. You can pretty much imagine what the conversation is going to go like. It has limited memory. When you go to a customer service agent, it doesn't go, hey, welcome back, John. A month ago, you asked us about XYZ. How's that going for you, right? So it kind of remembers what we're talking about at the moment, but it really has no long-term memory. It can use tools, but generally in a limited way. You're not going to get them to do a whole lot of interesting things for you. If the agent is confused or overwhelmed, almost instantly they're going to pull in a human, right? Oh, this we need to issue a refund. We need to whatever. And so they have some notion of tool use, but not strong. And of course, they're grounded in company truth, right? They'll answer questions about the products. They will answer questions about the return policy, but generally they're not, intelligent across lots of different subjects. So those are the types of things that a conventional conversational agent has. On the right-hand side, what we're talking about today, and we're talking about through the rest of startup school, are agentic systems. Okay, these agents are different. They are task and goal-oriented. They are multimodal. So what does that mean? We're going to start to see Gemini, and I'm going to do some demos, and lots of people are going to talk about this, but I think it's really important to understand that multimodality is the agent's ability to perceive its world. So you can talk to the agents, they can understand speech, they can see video, they can see images, they can reason about that video, they can reason about those images, they can output in images, they can output in speech, they can output in text. So there's lots of different ways for these more complex agentic systems to interact with their world, which means interacting with our customers. Okay, so that's number one. They are goal-oriented and task-oriented. They have a goal, they have a task. This is what I do. I'm going to go do this thing for my customer. I'm going to book a trip. I'm going to, fix their code. And instead of being an assistant that, okay, gives me suggestions when I hit tab, no, this agent goes off. It's a developer. It might work with a QA agent. It might work with a product requirement agent. It does much more complicated interactions. Its goals are much more complex. It works across lots of different capabilities. So a single agent may not do things. A single agent might aggregate lots of calls to other different agents. So we're going to talk about how that might work. But you might have a travel assistant agent that calls another agent to book a hotel, and calls a second agent to book a flight, and calls another agent to give the customer information about where they're going, and that sort of thing. And then it aggregates everything together and has that conversation. So really, the right-hand side is what we're talking about with agents all throughout this course. So the reason this is important is agents on the left are really a subset of agents on the right. If you can build agents on the right, you can build agents on the left, basically. All right, so let's move on. I love this definition. I love this white paper. This is a Google white paper. The link is down below. I grabbed this definition because I think it's really clear, right? It makes it very clear what we're talking about. So it's generative AI, right? This is all what we're talking about. And I'm going to dive into a little bit of that today, but I think this is basically assumed at this point. What I'm talking about is an agent that's powered by Gemini or Claude or, whatever, ChatGPT, some sort of intelligent agent sitting underneath that's generative AI. It achieves goals, it observes the world, just like I talked about, and it uses tools to accomplish those goals, right? These are the things that we want our agents to be able to do. And if you check out this white paper, it's great. I gave you the link here. It's a lot more. You can dive much more deeply into the thinking. Really wonderful, wonderful paper. So put this down. Oh, here we go. Here we go. All right, we're going to do a demo because we got to do demos and not just slides. So I go over to and I share this tab, and then you'll see my tab. All right, and I'm going to go to ai.dev. Okay, AI to score. I don't know, but score AI. I don't know who did that or how that happened, but score. Okay, so yeah, ai.dev is where you can go, and this is Google AI Studio. I'm also going to talk about Vertex AI, the differences, but we're going to start in Google AI Studio. The reason I want to start here is because this cool little function here called build. Okay, and I want to, let's see if I want to build a travel agent assistant that is, if I can type today, that is grounded using Google search, and we'll talk about what that means, that answers questions about where I want to go. All right, and then we'll let Gemini go do its work. And I don't know how many of you are addicted. I am absolutely addicted to looking at the thought space that the agent is building, that the model is building. And I don't want to dive too deeply into this. I'm absolutely fascinated by this. This thought space is emergent from reinforcement learning. So this is not programmed. This is not given to the model. The model learns as it is being trained what the sort of things it should put in its thinking is. And it just so happens that the model learns through reinforcement learning, hey, I should build what looks like a PRD, what looks like a product requirements document, and I should figure out how to ground on Google search, and I should call the Gemini API. The model is not told this is how you should reason about this problem. This is absolutely emergent, which is fascinating to me, is that when the model is given a problem, it comes up with reasoning that is very close, in most cases, to the way a human might do it. I think that's tremendous. So it's going to take its time. So I'm going to jump over and we'll go back. But the output is going to be basically an agent. Okay, it's going to do some stuff. I'm going to have the code, so I can edit the code. I can look at the code it's written, and I just want to see. Oh, it's going to start. It's going to start coding. Come on, start coding. Okay. It's got the code. It's got my agent. I can ask my agent, I want to go to Paris, France. What is the weather like there? All right. Go, little agent. Okay. And now my little agent's going to go, and it's going to call the Google Search API because I asked the environment to build an agent that was grounded on Google Search. So it's going to give me my answer. It's going to tell me about Paris, France, and it's going to tell me the source from Google Search where it got its information. And this is, we're going to talk more about grounding. We're going to talk more about what that is. All right. Jump back over here because I think this one's going to start building eventually. You can see it's reasoned about the problem. It's building subsections of code. And then what it's going to do is start building out this agent. I'm ready to ship right there at the bottom of its thinking. So really, really cool and interesting. All right, I'm going to let that agent continue. But what we saw, what we were able to do, it will get the code right here. I can download the code. Okay, that's fantastic. I can save it off. And this is really cool right here. I can deploy this with one click to Cloud Run. So if here it goes, building out the agent. So if I click here on Cloud Run, it's going to say, okay, what GCP project do you want to deploy this to? And it'll just one click deploy. I have to have a GCP account and all that good stuff. But it will take that and deploy it to Cloud Run, and I can get this live very, very quickly. So I think that's super cool. And that is AI Studio building a conversational assistant. And here we go down to the bottom, almost done. Go, 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 little agent. And last check mark. Oh my God. Oh my God. So verbose. Okay. You get the idea. And it's gonna go ahead and build that out. So this is a really cool place to iterate quickly, to start building agents. You can get the code, you can see how the app is built, you can see how the APIs are called, you can ask it to build all sorts of different agents. Tremendous set of examples here. So absolutely do check this out. And now let me jump back to the deck, share this tab instead. All right, well, that's it for my agent talk. We've talked about what an agent is. We've seen how to build an agent in real. Okay, I'm joking. We built the conversational agent on the left. Now we're going to talk about building the agentic system on the right. So the reason why we're not focusing on the conversational assistant on the left is because it's become trivially easy to build at this point. I can go ask Gemini, build an agent for me, and basically it does. So it's a much more interesting conversation to talk about agentic systems. And that's what we're going to do. I need to get my little other window back so I can know how much yakking I've been doing. All right. So let's start to answer this question, why agents? Everywhere you look on social media, it's agents, agents, agents. Everyone in AI is talking about agents. What's the motivation? What's going on here? So I've been at Google Cloud about a year. And when a buddy of mine called me up and told me about the role, and he said, hey, we're working with startups at Google, you should come join us. I thought, all right, that's interesting. That's really fun. Let me think about if I was going to do a startup again, and I've done many, both successful and many failures, but some successful. Knock on whatever material this is. I think it's cardboard. But I started to think, if I was a founder today, and this was about a year ago, what would I build? Okay. And I started to categorize. All right, there's the hardware, there's the platform, there's the software. What would I build? And what would someone want to invest in as an investor? Where would I get my seed money? How are venture capitalists thinking about this? And I kind of came up with this structure. And the answer I came to a year ago was I would build a vertical agent, right? Now, what I'm going to try and do is explain my motivation for that. Why did I come up with that a year ago? What information did I use to come up with that? And why that might help inform you why your startup ought to be doing the same thing. Okay. So if you look here on the left, this is the foundation, right? These are where the big players are. These are the hyperscalers. These are Google, Microsoft, NVIDIA, Amazon are all playing here. OpenAI, or Anthropic, and they have spent literally billions upon billions of dollars building these models. These models are not cheap, right? We all know this. And, a few years ago, if you wanted to play in a space as a startup, you would need to kind of play in this space. And we've seen a lot of very successful startups that actually played in this space. This is the foundation layer. This is what we are going to build our agents on top of and build our business model on top of. We don't need to repeat this work. There are some startups, DeepSeek comes to mind. There are going to be innovations in the hardware space, in the platform space, in the model training space. Those are going to continue to happen, but they're going to be well-funded. They're going to be expensive. They're going to be right difficult. Okay. These models that have been built are incredible knowers. They know things. We ask them questions. We have chats with them, and they know, oh, you should do this. You should do that. Here's information about what you just asked. They are knowers. Agents take knowers and turn them into doers. So knowing was not enough. We wanted these guys to actually, and gals, whatever they are, I call them it, but you may call them he or she, I don't know. I call them it. We wanted it to do something. Don't just talk, go do it. Go do something for me. And so what we're trying to do is turn it from knowers into doers. And that is the right-hand side. This is the value side. This is where the money is. This is where the value is. And this is where we're going to compete as startups, right? This is the value layer. So what does that mean? That means building vertical agents that don't just know about things, they actually do things. If you're helping an architect design plans, generate compliant blueprints, for example. If you're helping an attorney or a paralegal come up with a document or a brief, know the law, flag some cases they might see, flag some evidence they might be able to use, right? Do something. If you're helping my customer, help them book travel, help them, make plans, help them do something. So this is what we're trying to do in the value space, is turn these knowers into doers, because that's how we're going to make money. We're not going to make money competing with Google in the knower space. We're going to make money competing in the doer space. And that's where your capability and your knowledge starts to become very valuable as a founder. What business models can you disrupt? What have you experienced in corporate America or corporate wherever you are in the world that you can do better, that there's a pain point? That's where we're going to focus our business model, and that's where we're going to focus our agents. It's really interesting to me. And a year ago, I thought, Google is the only company on earth that innovates across the entire set, from the foundation all the way to the value, from innovations in hardware. So we just I guess it was at Cloud Next, we just launched, or maybe it was IO, the V7 of the TPUs, which are unbelievable. We innovate at the platform layer with Vertex AI and GCP. We innovate at the software layer. We innovate at the agent layer, all the way up to the inference layer. So Google is the company that innovates end to end. So if you start to ask yourself, hey, why is Gemini so good? How are they able to come up with, every month there's a better and better and better Gemini model? What's going on? Okay, this is why. Because there's innovation at every layer of the stack, not just in one layer of the stack. And Google is singular in that regard. All right. But how does that make us money? That's cool. I get it. Vertical agents make sense. Let's talk about how we make money. Where's the value? Okay. If you look at the corporate world, this is the world we know. You got a human layer that interacts with a software layer, right? So we human agents go to work every day. We interact with our software. We do stuff. We coordinate across different pieces of software. We interact in these layers. The first layer, the software as a service layer, we know it well. There's lots of companies here, right? Tons of successful startups. It's, Salesforce and NetSuite and, Figma and lots, and just on and on and on and on and on. Software as a service layer. It's so well known. We meme about it, right? What XYZ taught me about B2B SaaS or whatever it is, whatever that goofy meme is. But the second layer is the human layer. And this layer is filled with talented, brilliant, hardworking, expensive people. And it's inefficient. Anyone who works for a large company knows this layer is inefficient. Things are hard to get done, right? It takes us lots of time to interact with this software, other systems, coordinated across systems. And in fact, if you redrew this the way it ought to really be done and scale it by cost, okay, your enterprise might pay hundreds of thousands or millions of dollars for a software license. That's great. So if I save you 10% of that, I save you $100,000, $200,000. That's pretty good. But if I save you 10% in the human layer, I save you billions, right? So if I make your human layer more efficient, That's where the money is. Okay, that's where startups are working to disrupt. I'm going to make it so you don't have to interact with your CRM and your inventory system and your shipping system and check across a whole bunch of different softwares and check across this and that and do all this work across spreadsheets and everything else to get the information you need. We are going to build agents that help people be more efficient interacting with this software so they can do more and more important things than all the inefficiencies that are at this layer. So this is where vertical agents play. And this is why I believe this is where we ought to be building our startups to really be disruptive. Okay. Maybe you agree with me, maybe you don't. We'll talk about it in the Q&A. Tell me why you think it's right. Tell me why you think it's wrong. Maybe there's things I haven't considered. Would love to talk about it. But at least hopefully you see some of my thinking on why, if I were a founder, that's where I think I would be focused. So why now? What the heck happened? We're going along just fine. And all of a sudden, boom, 2025 is the year of agents. Why? What happened? Well, this is a little bit this is kind of the evolution. And I think you'll agree this is where we went. I'll show you why I think it's not exactly the right answer, but it's foundational. We started with the models. We're prompting them. We love the models. This is where we fell in love with ChatGPT a few years ago. It's only been a few years. Crazy. We fell in love with Claude. We fell in love with Gemini. We love chatting with them. We love using them. They're fantastic. We started to understand, however, they can be wrong sometimes. They can be confidently wrong sometimes, right? And so we needed to do some things before these models became super useful in important places where it actually needs to be right. So we kind of came up with something we had known how to do, and we've known how to semantically compress documents through vectorization and go and retrieve those documents from a Elasticsearch or a database or what have you. We've known how to do that. So we said, hey, let's go ahead and do that. And we'll help the model. We'll ground it in some certain bit of truth that we decide. And that worked great. But to me, it's always been a half measure, right? Semantic compression, vectorization. When you take a document and you compress it semantically using vectorization, you lose information. There's just no way around that. So you're not going to get around the accuracy recall trade-off, right? You can either be highly accurate and maybe miss some things, or you're going to, bring back everything and be irrelevant. Cosine similarity is cosine similarity. The math is the math. You're not going to get around that. You can build agentic RAG. You can build an augmented RAG. You can do whatever you want. But when you semantically compress, you lose information. Bottom line. Okay, so why is it different now? The magic of the transformer was attention. The magic of the transformer was positional encoding. Those things don't exist in standard vectorization. So you're starting to see we're re-ranking, we're pulling out our documents, we're letting the models try and understand what is in there. So we're making it more efficient, but we're taking advantage of the magic of the transformer to go and do this work. And that's why, in my mind, RAG has always been a half measure. If you can take your documents and just give them to the model and the model can reason about them, that's the best possible scenario. Now, that takes a very large context window. That takes a lot of attention heads, all that good stuff. And we'll talk about Gemini and how it's got a huge context window, but that's not always possible yet. But it is ideal because then we get attention, we get positional encoding, we get all the magic that the geniuses who build these darn things have come up with to understand these documents. And we don't lose information in semantic compression. And now we get here. We've got tools. We've got RAG. We've got grounding in truth. We've got all these things. And now we're to the point where, hey, we can start to make these agents. We've even arrived at reasoning. So we have models that are very, very good at coming up with ideas and coming up with ways to reason through problems and giving themselves thought space that actually gives them step-by-step ways to solve these problems. So we've arrived at sort of the state of the art. We're right at the cutting edge here, right? There are no agentic systems deployed with hundreds of agents running all around corporate America doing all this great stuff. We're not there yet. We have the approaches, we have the protocols, we have MCP to call tools, we have A to A to call other agents, we have enhanced grounding, we have grounding with Google search, we have vector, right? So we have a lot of capability at our fingertips where we can actually accomplish these goals. I said kind of because that's not the real reason. Advancements in technology come through confluence of different things happening in the technology space. I'll give you some examples. When the cost of bandwidth dropped and the cost of storage dropped, we got Dropbox, Box, OneDrive, right? Those things needed to happen before we could have data in the cloud. And once we had those things, we instantly got a lot of players in that space because technologies came together to make it possible. We tried. There were many, many companies that tried to do Uber with flip phones. Okay, back in the day, long time ago. Yes, I'm old. Stop making fun in the chat. It didn't work. Drivers couldn't find passengers and passengers couldn't find drivers. Why not? Well, we didn't have military grade GPS and smartphones in our pocket, and now we do. And when those things happened, when we got very high fidelity GPS, we got smartphones in our pocket, everybody's got a smartphone, now everyone has GPS, now Uber comes, Lyft comes, now we can do this thing because we're capable. These technologies came together and they started to make other use cases possible. So what's going on with agents? Multiple technologies are coming together. The models. Okay, I was doing this in 2020, 2021. The models were not good. They were not smart. They were expensive, horrendously expensive. Okay. They didn't have reasoning. They were small. We were just, okay. The tools. So the models have become cheaper. They've become faster. They've become powerful. The tools, we didn't have the tools. We didn't have LangChain and LangGraph and ADK. And there wasn't this ubiquitous API culture where we can just, call everything through an API. So the tools have started to come together where it's now becoming possible to build these things. And the platform, the hyperscalers, the GCP, Vertex, can I get these out there and can I have these end-to-end tools where I don't have to do all the work, where I don't have to host everything, where I don't have to handle every little bitty detail of my deployments. And when these things came together, we got agents. So in each one, it's pretty obvious and self-evident how these things came together. There's just a radical drop in cost. Intelligence is going to zero. It is absolutely going to zero. It's going to be cheap. It's cheap already, very, very cheap. Gemini 2.5 Flash is unbelievably smart for how cheap it is. There's other models. I'll call your attention to, I don't have a slide on it, but Gemma 3N just blows my mind. We'll talk about that a little later, but these models are 3 and 4 billion parameters. They take up 2 and 3 gigabytes of memory. They run on your phone, and they're nearly as conversational as frontier models were 3 or 4 months ago. It's insane how good these models are becoming. It's hard to wrap my mind around it, frankly. Multimodality, we talked about that. Massive context windows where we can put those documents in the context and let the model reason about them better. So, we've all seen this happening right before our eyes. The tools, we've got the vector databases. We've got this kind of explosion in capability. Frankly, just as a parenthetical, I don't think we solved this problem. I think there's a lot more work to be done, obviously, on how memory is distilled. What does a distillation of memory look like? What does long-term memory look like? In humans, generally, we consider that to be dreams. What do these LLM dreams look like? Like, what does this look like? And I don't think it looks like relational data, honestly. That's how we're doing it. That's what we're doing right now, but much, much, much more to come on how do we distill memory? How do we pass on this long-term information that we need. I don't think it looks like a SQL database, frankly. Explosion in capabilities, your function calling, your APIs. This is all well understood. LangChain, LangGraph, ADK, and ubiquitous APIs. And the hyperscale infrastructure, right? It's elastic, it's cost efficient, it's global. You don't have to build this footprint yourself. You can use Vertex AI, you can deploy your agent, you can scale it up, scale it down, save lots of money, put it global, right? It's all just right there, built for you at your fingertips to use as a tool. So the confluence of these technologies has brought us agents. We can now do it. And this is a good time to introduce a high-level architecture. We're going to talk about this high-level architecture throughout the course of Startup School. So obviously, I'm not going to go through every single bit of this today, but I wanted to introduce this architecture as where we're going. By the end of the course, you will understand all the pieces of this, how to build them, how they come together, why they're there. You'll have a very good idea of what this overall agentic architecture and this cognitive architecture looks like. So now let's talk a little bit about why Google Cloud. So we've got this architecture, we've got these confluence of technologies, everything is good. I want to build my agents. Why should I build my agents on Google Cloud? Well, I will tell you. So let's map these concepts and ideas to Google Cloud. So on the left-hand side, you have Gemini. That is our frontier model. It is awesome. It has lots of different flavors. We will go through that. In the middle, you have Google ADK, the Agent Development Kit. Okay, I will give you the motivation for why we built ADK, where it fits in the world of different frameworks you might choose, and what the deal with ADK is. And then there's Vertex AI. That is your end-to-end AI and ML platform where you can build and deploy agents, build and deploy ML solutions, build and deploy AI solutions that scale globally, scale up, scale down, do all your HIPAA, you can make them HIPAA compliant, PCI compliance, got all the abilities, your observability, your monitoring management, it's all there for you. Okay. So let's take a look at Gemini. I wanted to talk about this slide. I mentioned it before. Gemini 2.0 and 2.5 are very, very different models than the Gemini 1.5. They are natively multimodal. If we have time, I can demo what that means. But suffice it to say here, they understand and can reason about what they're given. So if you ask Gemini, hey, look at this image and put a bounding box around the armadillo, it will find the armadillo, it will understand the picture, it will understand the animal you're talking about, it will put the bounding box, and it will generate a new image with the bounding box. We're not going out to another model. It's not writing Python code. It's not doing image segmentation with YOLO and then finding an animal and then figuring out the bounding box using code. It's not doing that stuff. That's the way we used to do it, okay? These models are natively multimodal. That's what that means. When you speak to this model, it's not doing speech to text and text to speech, and it is understanding what you're saying, and it is natively outputting speech. That is a different world. That is a different world than where we were. All right, so let's go to lots of different flavors of Gemini. Why do I bring this up? Because cognitive architectures in the real world use lots of different models. You've got the pro model on the very left-hand side. These are very conversational. They are very large. They capture nuance in a conversation. They are very powerful, but they tend to be expensive. The flash models are fast. They're cheap. They don't capture as much nuance in the conversation. They might not be the best choice to, say, interact with your customer. You might want a larger model, a more interactive model that will capture more of the nuance to have that conversation with your customer. But you might use a flash model or even a flashlight model to generate a Python function that parses a string. You don't need Gemini Pro to do that. And you certainly don't need 2.5, which adds reasoning. So cognitive architectures that we build in the real world are going to leverage lots of different models. They might use reasoning models when you need to solve a hard problem. They might use pro models when you need to have a conversation with your customer. And they might use flash and light models when you need to do tasks or call tools or things that are relatively simple and can be done reliably. So it's great that Gemini has this set of choices where you can build out this realistic cognitive architecture and have the right model for the right job that's the best, fastest, and cheapest for what it needs to do. The world is not going to be one gigantic model to rule them all. It's just going to be too expensive, too much latency. It's not the way we're going to go. We're going to go lots of different agents, small models that are super smart, like Gemma 3N, and we train it to do one thing really well, and it's practically free, and we have hundreds of thousands or billions of these things all working together. That's what it's going to look like. The future looks like lots and lots of agents that are really, really small, fast, and smart doing things together. It's more like ant algorithms, right? It's more like how an ant colony works, not like this giant super genius can tell you everything. This is not the way things are going to work. I know there's respectful disagreement there. I think they're wrong. Okay, Gemini 2.5 is the reasoning model. The reasoning space, like I said, is endlessly fascinating to me. It is created by reinforcement learning for the most part. And that means it is emergent. We don't give the model, hey, here's how you should reason about problems. It figures it out. To me, that's awesome. So we are in preview with many of the 2.5 models. You can use them in AI Studio. You can use them in Vertex AI. They are extremely powerful. They are extremely intelligent. We have pro models that are super conversational and do a lot of reasoning. And we have flash models that are very fast and cheaper and are still capable of doing quite a bit of reasoning, but still in a faster and cheaper way. So again, if you need reasoning, you're going to pull a reasoning model into your cognitive architecture. You're not going to just take a reasoning model and throw every problem at it. It's the wrong architecture to gather everything together in data, dump it on the reasoning model, and ask it to do all these things. It will probably work. It'll be slow and it'll be expensive. We're doing the same thing we do in software engineering when we have problems that are parallelizable and can be done, by smaller little functions and little components. We will build agents. We will have these agents do things that are easy to do for them. We will have small models that are very cheap. And then we might have a reasoning model aggregate all the work of these smaller models together in a solution to our problem, right? We're not going to just dump everything on a reasoning model and go. Not yet, anyway. We might get there eventually, with some hardware and some software breakthroughs. I think we're a few of those away from the point where this will be a reasonable cognitive architecture. But today, we really need to break up our problems, use smaller models, use agents to get stuff done. Okay. Let's do another little demo here. What demo do I want to do? I think we tested this demo. I just want to get a little bit of excitement here about where, okay, here's it built out. I'm going to share this tab so you can know what I'm talking about. Okay, here it built out the agent. Check. Gives me the code I can edit, lets me deploy, all that great stuff. So what I want to do here is give myself a new chat, and I'm gonna go to stream, and hopefully this will. We tested it, so it did work. So I'm going to give it my webcam, and I'm going to talk to Gemini. Hi, Gemini, can you see me?
Yes, I can see you clearly.
What am I doing?
You appear to be sitting and looking at something, possibly a screen, with your head. Behind you, there are some plants visible and a light source, possibly
what kind of plants are they?
The plants look like they might be trailing plants, possibly something like pothos or a similar vine, hanging from the background.
Anybody know if that's true? I don't know if that's true. Sounded pretty good to me. Let me give it my screen. All right, so what do I want to do? I want to give it itself. Gemini, can you see my screen?
Yes, I can see your screen. It looks like you're on a page with the Stream Real-Time Studio interface.
I want to add Google grounding through Google search. How can I do that?
Okay, I can help with that. First, please go to the Tools section on the right-hand side.
Okay. So you start to understand where this is going, right? We're getting closer and closer to the ubiquitous AI presence. Hey, computer, how far to Starbase 121 at Warp 7? I know there's some nerds out there laughing nerds, right? Okay. This ubiquitous AI presence in our lives, right? It can see, it can understand what I'm doing on my desktop. It can help me do things. It can hear what I'm saying. It can understand the videos. It can understand the images. It can reason about what it's seeing. It can be grounded in the documentation for the tool that you're using. We're starting to get to the point where this is a very realistic scenario of an omnipresent AI in our lives. So I think that is very, very cool. And you can go play with this for free at AI Studio. You should go do that because it's fun. All right. I think that's awesome. Let's go back here and we'll do this. Okay. All right. Let's talk about the Google ADK. And I need to bring back my time window. All right. How are we doing? We're doing fine. We're doing just fine. So Google ADK. Why did we build this? Okay, there's lots of frameworks out there. There's our friends at, LangChain, LangGraph. There's lots of different options for you. So first, let's talk what it is. I stole this. The source is there. So if you want to go check out the source, you should. I stole this because I think it's a really good description of the ADK. And so I like to define things before we talk about them so we all are all on the same page of what's being talked about. And this is what we're going to do. We're going to develop these AI agents. We're going to be using the generative AI, the popular LLMs. They don't need to be Gemini. They probably should be Gemini. I don't work for Google DeepMind, so I'm allowed to say that. But you can integrate Claude, you can integrate ChatGPT, you can integrate whatever model you want. You could host your own Gemma and integrate that. So lots of different options here for the agents. And, I'll just take an aside really quickly. I'm in the United States. I'm here in beautiful Oakland, California. I work in San Francisco, California. It's a cloudy day here. Here in the US, we tend to assume omnipresent internet that is always on, that is always high bandwidth. We always have access to, wherever we are to the internet. And when we build products, we think about that a lot. But lots of places in the world, that's not the case, right? You don't have omnipresent internet. You don't have high bandwidth all the time, but you still want to have AI. And you start to think about, okay, how can I build these models? How can I use these smaller models on my device? Right. And so you have these models like Gemma 3N that take up 2 or 3 gigabytes of RAM. Now you can start running them on your device. You can start doing useful work when you don't have an internet connection. And then when you do, you resync up with the larger model and you have this kind of symbiotic relationship between small model on the device, large model in the cloud. It's a really cool scenario that's going to unlock a lot of use cases. So, when you're thinking about business models to disrupt, compute on the edge is a good one. Okay, let's keep going. So here's the motivation. This is XY. On the X axis, we've got less flexible to the left, more flexible to the right. On the Y axis, we've got difficult at the bottom, we've got easy at the top. And, we can play a little game where it's like, figure out which slides in JP's deck were built by professionals and which were built by him. I think you all know who built this slide, so forgive me. On the bottom right, you can build it all yourself. You start from scratch, brand new virtual environment. You make your first Python file and you just build out your agents and you go. And that is very, very flexible. It's also very, very difficult. Okay. And the top left, you've got out of the box solutions. You know what this conversation is going to look like. You know what the interaction with your customer is going to look like. You don't need to build out some crazy cognitive architecture that does all this stuff. You just want an agent that does X, Y, Z. And maybe if your customer takes a left turn on you at some point, hey, you can pull in a generative model and handle it at that juncture. All right. Going up, You've got LangChain, you've got LangGraph. They're low-level frameworks. They're fantastic. Coming down, you have your low-code solutions, your dialogue flows, so you have a little bit more control and power. And the sweet spot, at least the sweet spot that we were aiming for in ADK, is really this balance of capability, expressibility in the ideas that you want and the power of the agent, but also some ease of use, right? Some way to build these cognitive architectures where you're not handling memory and moving data back and forth between all your agents and scaling up and down and doing all these things that a framework could handle for you. So we're really aiming for this sweet spot in the market. Does that mean you can't use LangChain and LangGraph? Absolutely not. You can. You should. We had some great blog posts from our friends at GDM about how to do agents with LangChain and LangGraph. Amazing stuff. So this doesn't mean you have to use ADK. It doesn't mean you can't use them in conjunction. You certainly can. So that's just the motivation and where we think this product sits. Okay, so let's look back at our architecture. This is where we are. So I mentioned we were going to, kind of introduce this architecture. We're here at the agent orchestration layer, right? All the things that we want to do with our agents working together, talking back and forth, passing data, scaling up and scaling down, doing all these cool things. This is where in our architecture we are living at the moment. This is, what the idea here is. It's pretty straightforward, pretty high level. You have your requirements coming in, you have your interaction model, you have your prompts, you have your tools, you have your, prompt engineering where you give it a personality, you give it a model. It can use MCP to call out to tools. It can call out to a human as a tool. So if you think, oh, hey, my agent needs help from a human, human interaction is a tool. We're just tools for your agents. That's what's going to happen to us. Okay. So it's just going to be call out to a human. Hey, I need help. I got this tool that's a human. Speak for yourself, buddy. Okay, I'm speaking for myself, the tool. Okay, we've got agent-to-agent framework that we announced back at Cloud Next, I think, and that allows these agents to work together. So we're starting to get the protocols. We're starting to get the APIs. We're starting to get this architecture where it really is realistic to build this agent that is grounded, that can use different tools, that can access other agents and work together. And so this is where the ADK makes your life easier. And we're going to go in depth to the ADK. So don't think this is it, ADK done. No. I want to introduce these things at a high level, talk about the reason, talk about where they live, and then we're going to dive deep in how these things work. We're going to look at the code. We're going to do all that good stuff as the course of the of startup school goes. All right, let's talk about Vertex AI. What is this thing? This is an end-to-end AI and ML platform. Okay, what does that mean? We've talked about Google AI Studio, consumer product. You need a Gmail account. You go sign up. It's free. You get an API key. You can do paid tiers. If you want to set up a billing account, you can go up in the tiers, get more capacity. It is worth noting that when you're using the free tier, data is shared with Google. If you are using the paid tiers of any Google service, data is not used. So you are sharing your data with Google, and you agree to do that when you access the free tier, but you can add paid tiers. And then on the other side, on my right-hand side, we have Vertex. This is the end-to-end AI ML platform. This is where you start to think about, how do I go live to 10,000, 100,000, a million users? I have global users. I need a global database. I need data privacy. I need to be in, I need to bring my own encryption key. I need to do HIPAA compliance. I need to do PCI compliance. I need to do data sovereignty. I need to keep my EU data in the EU, and you got all these things that are not generally available in a lighter platform like AI Studio. So this is really built on top of the full power of GCP. You don't just need to use Vertex. Vertex can interact with Cloud Run. It can interact with Spanner. It can interact with PubSub. It can interact with the entire architecture of GCP to build out a robust, scalable, compliant architecture that works all the time. So We got vibe coders. We don't got vibe architects yet, right? So maybe someday put myself out of work, we'll have vibe architect where you can say, make this secure and make this compliant and make this scalable and make, go build me the Uber backend on GCP and it'll and get all done. And we ain't there yet. Okay. So this is the platform you use when you want to accomplish those goals. I bring this up because it's important to understand, platform as a service versus infrastructure as a service. We talk about this all the time. On the left, at the top, you've got Vertex. It's platform as a service, right? It is a managed service. You call service endpoints to get work done, right? You give it your agents. You say, I want to scale up to, whatever. I want to scale down to 1. I want to use this memory. So you have this managed environment where your agent is running. In exchange for a little bit less flexibility, you get cost optimization. It's cheaper, right? You can go grab virtual machines in GCP and put a huge GPU on there and hold it 24/7 and do inference on your, gigantic cluster of GPUs. Awesome. Very expensive, right? So you can do the IaaS route. You can use Kubernetes engine. You can grab raw metal VMs, but that's back to the flexibility versus ease of use discussion. So Vertex AI is more on the platform as a service, easier to use, lots of managed services. GKE, Google Kubernetes engine, starts to be more about, hey, I'm going to control a little bit more of the hardware myself. And you have this balance of capabilities. So you're going to find it all in GCP, obviously. I don't find the speeds and feeds discussion very interesting. People ask, can I build it on GCP? Yes. Can I build it on GCP? Yes. Okay, all our stuff's built on GCP. You can build it on GCP, I promise. It can be built. Okay. The question is how? How much is it going to cost? How do I do it? What do I do? How do I make it secure? Where do I put my data? How do I make sure I don't wind up on the cover of the Wall Street Journal for all the wrong reasons because I vibe coded my way into giving my customer data away to everybody who attacked my front end. Okay. Platform as a service, infrastructure as a service, Vertex AI, other services. So we get that. Okay. Vertex AI has got a ton of stuff. No way can I go through it all today. Check it out. It's got a lot of great stuff, but where we're focused today is in the agent layer. I love Model Garden. It's amazing. I usually demo it. I just don't have time today, but it's cool. Check it out. So Vertex has a lot. We're going to focus here, particularly Agent Engine. This is where we will deploy our agents from ADK. So you build out your agents in ADK. You're going to run them locally. You're going to test them. You're like, I love this agent. My God, I'm going to make billions. Boom. I deploy it to Agent Engine in Vertex AI. It's going to give me that scalability. It's going to give me that management. How do I actually live with these things in the real world? We've got Datadog coming up. Aaron, thanks a lot, Aaron, put Star Trek nerd stuff in my head right before my talk. She says, when Pulaski calls data, and she goes, what's the difference? And he goes, one is my name, the other is not. So we're going to have Datadog come and talk about observability, management, logging, all that cool stuff, things you need to do when you actually have these things going in the real world. How do I evaluate my models? How do I set up a rigorous scenario where I know I can use Flash Lite, or I might need to bump it up to Flash or even Pro? Like, how do I set up these evaluations? How do I do quality? And of course, it's all provider agnostic. You can use any framework. You can pull any one of our partner models in. You love Claude, you can use Claude. You want to use ChatGPT, use ChatGPT, right? It's provider agnostic. It's framework agnostic. It's all right there for you. Agent Engine, super cool. Okay. This is another view of it, a more, lower level view. You have the runtime. Context management is really important. So, this is similar to, maybe you might think about it as session on the web. Like how do I manage and maintain this session with all my agents? I've got all these agents coordinating with one another, doing all this stuff. How do I pass data back and forth with them? How do I, maybe I have things that can be done in parallel. Maybe I don't. Maybe some needs to be done in series. Maybe some needs to, before I start doing this task, the previous task needs to be successful, right? So how do I kind of manage this context, manage this information that's going back and forth between all my agents, right? You don't want to build that. You can. Heck yeah, you can, right? But there's a lot of effort, save that for somebody else. Make billions of dollars and, just use context management and platform as a service for a startup, right? It's fast, it's cheap, you get it going and boom, 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 done. Don't build all that crazy stuff. So anyway, this is where kind of Agent Engine lives and all the abilities live and all the different frameworks live. So that's kind of a good picture. This is where we're talking about this in our architecture. So this is when we start to talk about things like deployment. How do I do this? CI/CD, how does it fit into my, continuous development and continuous integration pipelines? How do I do my testing, my automated deployments? How do I get this stuff out there, right? How do I scale this to the world? How do I serve my customers, all across the world? How do I make this more scalable with PubSub and every other message passing approach or whatever you want to do? So this is where we're starting to think about, when I deploy this agent in the real world, how do I actually live with it? How do I make sure it's always working, always up, that sort of thing. So this is where in the architecture for Text AI and particularly Agent Engine live. Okay. We are at about an hour, I think. And so I'm going to show a little bit of the ADK. Again, I don't want to go in too much depth here. So others will do that. And so fear not, you will get plenty of information about the ADK throughout the course of these talks. However, just as an introduction, it's right here. You can Google it, you can find it, you can pip install the Google ADK, and there's lots of great stuff here. So you've got all your tutorials, you've got your quick start, you've got your your API reference, all that good stuff. What I want to do is go to the sample agents. Okay. So I'm not going to click on that, but I'll just pretend click, and then I'll share this tab instead. So this is where it would get clicked if I clicked on it. Okay. So this takes us to the, okay, this is not exactly what I want. I'll show you a little trick here. Maybe you know this trick, maybe you don't. I'm going to just change the .com to github.dev. Thank you, friends at GitHub. And now I have Visual Studio Code in my browser. Thank you, friends at Microsoft. Love Visual Studio Code. Now I can go to Python and I can go to the agents. So when you're building out your agents, when you want to figure these things out, when you want to kind of test and run and deploy locally, these are great place to start, right? I want to understand how these things are built. I'm going to understand how they talk to one another. There's every sort of example here. We talked about a travel agent, so I'll just choose that one. It's got code to deploy, the ability to deploy to Vertex, the ability to deploy to Cloud Run. Both have command line. It's got some evals set up for you, a framework where you can put in your evaluations and build your evaluations, of course, your tests and all that good stuff. But we will look at the core of what's going on here, and that is the agent file. So that's probably too small. Let's see if I can. Okay. So this is how we're going to do it. And I think this is important to show because it starts to kind of get your mind thinking about how I would build this out and how I would compose these sorts of things, these cognitive architectures. So what's going on here? I start with a root agent. I tell my root agent, here's your model. In this case, I've chosen Flash. I could choose Pro, whatever. I tell it what, I give it a description. And when you're building out agents, when you're building out any kind of interaction that's going to be with a large language model, it's important that when you describe things, when you name variables, when you make comments, when you give a description of a function, you do it in, you do it very descriptively, because the models are going to look at these things, read them, and try and understand how they ought to be used. Okay. So I have my root agent, and I have a bunch of agents that do stuff for this root agent. I've got an inspiration agent. Hey, my user asked me for a fun idea. What should they do? And the inspiration agent might go, well, do you like being outdoors or indoors? Do you like, you don't want your inspiration agent to recommend fishing if your customer don't like fishing, right? So it's going to do that job. It's going to understand who the customer is, what their proclivities are. Maybe it accesses some memory about them. Maybe this person, maybe what they like, and you're like, oh, John really loved going skiing, or John really loved going to Vegas. We should recommend he go to, whatever, Atlantic City. So, okay. We're booking agent, that's going to handle our bookings, plannings. Okay, we get the idea. But these sub-agents can be composed by our root agent in interesting ways, serially, parallel. Each can have their own tools, each can have their own grounding, each can have their own model, each can have their own prompt. So you can prompt engineer each one, teach it how it works. So this is really the root node of what's going on. But it's very, very simple to see how this is then composed. Okay, let's get rid of that. Let's see our prompt. So the prompt file, this is just where you do your prompt engineering, right? And each agent has got its prompt. You tell it, hey, you're a travel agent, you're very friendly, you work with my customer, right? This is where you tell it how it works, tell it what tools it has, what to do, not to do, all that good stuff. You simply give it a character, you give it what good answers look like, you give it what bad answers look like, you give it its attitude. This is how you can expose your, brand to the world. This is where you kind of do, hey, this is your attitude. This is what you kind of like, and that sort of thing. Your customer is this sort of person, that sort of person. You're talking to teens, you're talking to adults, you're talking to whatever. Okay. So that's that. And then just here we see the sub-agents, and each of our agents that we gave to our root agent has a sub-agent, right? Very straightforward. So we talked about the inspiration agent. Let's go look at that. And the inspiration agent, all right. Oh, come on now. All right. So again, we give it the model, we give it a name, we give it a prompt, we give it a description, we tell it what to do. There's lots of ways to configure these agents. We'll go into that in the future. How do I make it serial? How do I make it parallel? How do I do callbacks? How do I examine what's going on between these agents, right? When one agent tells something to another agent, I want to have an interception layer where I log that, I audit it, I make sure it's right, I apply some closed form solution, I apply guardrails, I do lots of different things as these agents are talking back and forth, right? The ADK gives you all kinds of interception layers and all kinds of ways to pass functions and all kinds of ways to build tools so you can kind of introspect what is going on between your agents, debug these interactions with your agents, right? You can't just throw all these agents out in the world and then your root agent goes, well, I don't know what to do. And then you can't figure out what the heck just happened, right? So you will see when someone demonstrates kind of the ADK web interface, it allows you to debug. It will give you a graph. It will give you reasoning. Here's why I called this agent. Here are the parameters I passed to this tool. Here's what was returned. You can flow through that and see where am I, going wrong, or which agent is not understanding what the right thing to do is, which agent is calling the wrong tools. So it's really this framework that allows you to get going quickly, but also build quickly and debug quickly, which is so important when you're working with, something that is essentially entropy at its core, right? These are not deterministic solutions. There's entropy at the core of these models. And so you can't always be sure. I got this a lot, not in my current company, but somewhere where I was before, I won't talk about. It's like, hey, we don't want it to say dude. Well, okay, don't say dude to it. Right? If oh, hey, dude, how you doing? And the model comes back, well, I'm doing great, dude. It's like, oh, but make it not say dude. Well, it's not a closed form solution, right? So there's always these funny issues. And again, each has their prompt. You get the idea. So this model, this agent has a different prompt. It has a different job. It has a different character. It has different tools, all that great stuff. Okay, so these are the sample agents at the ADK. Amazing place to go and get started. Download the ADK. It's got a local tool. So when you build out your agents, you say ADK web. It's going to bring up this the web interface that we've built for you. It's going to let you select your agents, interact with your agents, debug your agents. Super, super cool framework. You will learn all about it in the course of the conversation. But I just wanted to give this motivation and a little bit of how these things are formed, what the top level details are, so you can understand and imagine, start to imagine, hey, where is this going? What does my cognitive architecture look like on the ADK? How would I build out my agents, my sub agents? And I have this conversation with startup founders all the time, and they're doing the thing that I said don't do. They're pulling a bunch of data, they're handling it all to Gemini Pro 2.5 and going, figure all this out. It does work, but then they go, it's expensive. Right? So think about your cognitive architecture. I need a plumbing agent. I need an electrician agent. I need a carpet installer agent. My plumber doesn't know about installing carpets. My electrician doesn't know about roofing and drywall, right? You divide up your workloads and you divide up your use cases into logical components, and then you build each component separately. And then you have that really smart model at the top layer go, okay, I'm going to reason about all this good stuff I just got back, figure out who I'm talking to, understand my brand awareness and how I need to speak with this customer, and be very conversational going back. You save money, you save time, you build out this reasonable and logical architecture. It's all segmented. So when your electrician agent screws up, you don't go looking at your plumbing agent and all that good stuff. Okay. Just like software engineering. There's no magic here. Okay. Let's go back. Share this tab instead. That was the demo for ADK. Wow. Okay. How we doing? How we doing on time? Okay. Pretty good. We covered a lot. So that was a lot. We went through this kind of motivation. We looked at the hyperscalers and the things that the foundational models that have been built. We kind of thought about our reasoning behind where we might build our startup, how we might disrupt, where we might disrupt, how we would build an agent to do that. We talked about vertical agents. We discussed this confluence of technology, this really important set of things that has come together to really empower us to do this in a fast and efficient and reasonably cost way. So now is the time. These things just happened. I'm not talking about stuff that happened a year ago or 2 years ago. I'm just talking about stuff that happened a month ago. Okay. So, the pace is insane. Now is the time to take advantage of it. We talked about how the Google products, particularly the Google Cloud products, map to these important confluence of technology, the Gemini, the Vertex, and the platform as a service, and the platform itself, along with the tools, ADK. So a lot of great things, covered a lot. We'll go into lots of depth on each one of those things. But I absolutely and certainly appreciate you spending some of your valuable time with us and me today. I hope you found this valuable. I hope you found it informative and somewhat enjoyable. I do my best. So with that, I will call Aaron back and we will do some Q&A. How's that sound?
Awesome. Thanks, John. I was curious about the plants behind you, so super helpful to hear from Gemini.
Yeah, Gemini knows. I don't know. Gemini's way smarter than me on this issue, at least.
It was great. Very informative. We've got lots of questions for you.
Amazing.
In the chat and the Q&A. So
amazing.
I'm going to ask you a few and we'll see how many we can get through. All right. So first one, I'm interested in knowing how to build agents using vibe coding. What are the right tools that Google provides? AI Studio, Gemini Code Assist, or Jules?
All. Okay, all. So those are all orthogonal, right? They do some similar things, but not exactly the same thing. So AI Studio is a terrific place to start. It is specifically designed to help you vibe code with the Gemini API and the Gemini model. So you can go there. There's a ton of cool examples. I didn't have time to drain all the amazing examples that the team has put there, but they have put games and they have put different agents and they have put all kinds of stuff. So you give it your prompt and then you work with it, because another thing I didn't show is Gemini comes up on the left-hand side. So you can continue to iterate. You're not stuck with what is built. You can edit those files yourself. You can ask Gemini in AI Studio, hey, I'd make this blue red, make it put a hat on the bunny, whatever you want to ask it. And then you check it in. So you pull it down, it's all good. You check it into your GitHub, and that's where Jules comes in. Okay, Jules is going to look at your repo. Okay, so you're going to point Jules at your repo, and you're going to give Jules background tasks to go do. So you would say, one of the things I asked Jules to do is I forked the ADK, I pulled down the ADK, I pointed Jules at the ADK, and I started making additions to the ADK that I would want. So I told Jules, they've since added this capability, but I told Jules, build a command line option to deploy to Vertex AI. And it said, okay, I'll go do that. And then Jules goes off, really smart. And then it comes back with, here's all the chat, here's the PR, here's what I changed, here's what I did. And then I can say, okay, yeah, this looks good. I'll integrate this. I'll take this. So Jules is that kind of background agent that's going to take more complex tasks on your repo and go do them, right? So you can build the original MVP or the prototype, and you can iterate on it, make sure your customers like it. Very fast iteration in AI Studio. Then you can add those more complex and difficult features either yourself or in coordination with Jules, and then you can deploy. There was one other technology that was mentioned there.
Yep, AI Studio, Gemini Code Assist, or Jules.
Yeah, Gemini Code Assist is going to sit there in your IDE, whatever that is. I use Visual Studio Code. You might use Cursor. You might use Windsurf. You bring your own key, Gemini, and that's going to help you. Not only tab complete, but it's going to help you. You say, hey, Gemini, do this or that to the code, or why is the code this way, or why I got this error, what the heck happened. So that's going to inform you on tasks that you're doing in conjunction with the AI. Gemini, the assistant's not going to really go and change your code. If you say, hey, write a function that does XYZ, it will write the function, and you can look at it, and maybe you pull it over. You can highlight your code, and you can say, look at this code. What did I do? Here's the error I got. So all three, they're all tools. They're all great tools, but they all do a slightly different thing in this kind of world of vibe coding, so to speak, or even more. It's not just vibe coding, right? Jules, for example, and Gemini in the IDE are not just for vibe coding. And there's another Gemini in the Cloud Console. So when you go to console.google.com and you're interacting with GCP, the Gemini that's in there is super well grounded on best practices, on the documentation for GCP. So I've given up trying to figure out G Cloud commands at this point. I just ask Gemini, I'm gonna just give me a G Cloud command that does this. Boom, done. Right? I don't even try and remember anymore, which is great for people who don't remember so well. Okay, how was that? Reasonable?
That was great. Super clear.
Okay.
Somewhat related to that, we have another question about whether or not AI Studio is ADK enabled, or in other words, can you ask AI Studio to write the agent using ADK?
You can ask. I don't think so.
Okay.
I could be wrong. So if anyone else knows who's a moderator or a Googler and can correct me if I'm wrong, because I will tell you this. Our friends at Google DeepMind are shipping very, very quickly. So what is in the AI Studio today is not generally what's going to be in AI Studio tomorrow. So that is constantly changing, constantly improving, lots and lots of things on a day-to-day basis. Logan and the team are just crushing it. So I don't think so, but if anybody can check me on that, I would appreciate it.
Yeah, we'll get some folks to check and verify. That sounds good. All right. We've got 2 more questions for you. I think we can squeeze them in. So next one is, how do you break down real world problems into manageable chunks so that multiple agents can be summoned to work on them?
Yeah, absolutely. So this is, typical software engineering, single responsibility principle, right? So I'm going to think about my agents as far as, here's my work, here's my work breakdown structure. So you build a breakdown structure. How do I build a house, right? When you do a work breakdown structure of a house, you don't say, I'm going to build cooking, I'm going to build sleeping, right? You don't do that. You say, I'm going to build a foundation. I'm going to build my electrical system. I'm going to build my plumbing system. I'm going to build my frame. So you build your work breakdown structure on how I do the thing I want to do with least, single responsibility if I can. So I will come up with a certain set of agents, could be 3, 4, 5, could be 1 or 2, that do things and do them well. Now, in the world of agents, this will tend to be a tasks or a closely grouped set of tasks. Like I was saying, you might have a plumber agent, but that's complex, right? Plumbing is very complex. I'm not a plumber, but it gets complex, right? You could build plumbing for a house. You could be building plumbing for outdoors. You could be building a sprinkler system. You could be building plumbing for a 110-story skyscraper. Very, very different, very complex. Lots of laws, lots of rules, lots of regulations, lots of stuff you got to know when you do those kind of things. So you start to break down, what am I actually trying to build? What does this agent need to know? Okay, here's a reasonable set of agents that would do that. And presumably you are an expert at the top level thing. Like, how to build that, right? That's where you're bringing the value to the table, is like, I know how to do this better than other people, right? That's the core of your startup, is everybody else on earth is screwing up and I know what to do, right? And so you have that vision, and that comes from you.
Awesome. I think we have time for one more we can squeeze in before the final reminder.
Squeeze in, so don't talk so much. Okay, I got it.
Not at all.
Shut
Okay, so this one is, I think, will be helpful for a different portion of attendees. So how is Google architecture enabling non-technical founders to put their ideas into reality without having to hire a technical subject matter expert?
This is an amazing question. Boy, we have to squeeze this one in. You gave me this one. I love this question because it's so very, very important. We absolutely are moving in the direction of empowering more non-technical users, business users, to engage in software engineering. You will see much more of that coming out of our tools. We want that to happen, right? We want to engage more people. We want to bring more people into the process, right? We want to collaborate across these groups more effectively. We're not there yet. So when you interact in a vibe coding way, whether that's with Cursor or that's with Gemini or that's with AI Studio or any other tool, Replit, you get the feeling, and someone who's going from 0 to 1 in software engineering might really get the feeling that the agent is the lead coder and I am not. Well, that's not the way it is. You're still the lead engineer, right? You're still responsible for what gets built. When you hit deploy, it's you hitting deploy. It's you putting something out there in the world. And I've been working in software engineering 30 years. So these things come natural to me. We just don't think about them. But someone new to software engineering who we are trying to bring in might not know this. So you are the lead engineer. You are responsible for understanding security. You are the one responsible for making sure that your customer data doesn't get exposed. You are the one to make sure that all your systems are GCP helps, right? When you spin up Cloud Run, it's very locked down. You have to go and make a network. You have to poke holes in the firewall. You have to explicitly say turn on anonymous. Like, when you make things in the cloud in GCP, they're locked down, right? You have to open them up. You are turning the switches and turning the dials to expose more things. So it helps you in that manner. But at the end of the day, when you hit deploy, it's your responsibility. You're the lead engineer. So you have to know, yeah, I followed security best practices. I followed architecture best practices. I can deploy this thing in the world. I believe in it, right? And that means architecture reviews, and that means architects. We're just not there yet. where I can honestly tell you, just go vibe architect yourself into a secure system. Maybe someday, but you should still hire me or someone like me.
We'll
Not
leave it
self-serving at all. Not trying to save my own job. Anyway.
Awesome. Thank you so much, John. And I
Yeah,
did
of
just
course.
want to confirm for the group on the AI Studio ADK question, we had a moderator say, no, it is not enabled, at least not yet. So
Cool.
Thank you, Rolando, for confirming that for us. John, thank you so much for all your expertise. And
Thank
answering
you,
all the
Erin.
questions.
I really, really appreciate this opportunity. You are the genius. I'm so happy you gave me this opportunity. Thank you again.
Awesome. Well, thank you. We'll let you get some water and some food, hopefully. I'm going to just run through a few final reminders for everyone ahead of the session on Thursday. I promise that I will go through this quickly. I know we're at time. So first things first, for anyone who isn't familiar, just wanted to draw your attention to the Google for Startups Cloud program. So as you're starting this Gen AI and Agentic AI learning journey with all of us, we are confident that you're going to want to try the products and solutions you see referenced and discussed and demoed. So if you are a startup, you can apply for this program. It is up to $350,000 in cloud credits via the program, so that you can start building Gen AI solutions for your business pretty much instantly. We have different tiers, starting with a $300 free trial. We have a $2,000 start tier, and then we have additional credits to support your growth and scaling. So again, various support offers for every different stage of startup. We even have tailored programs for AI first startups and Web3 companies. So scan that QR code or visit the link on the screen. We've also pinned this in the Q&A section below the video. We'd be happy to chat about the program with you and how it can help you build, scale, and grow. All right, second thing, we know that you really started diving deep with John today. We covered a ton of technical and strategic ground. And so one of the biggest challenges after a session like this is really kind of taking your excitement and energy and knowledge back to your teams, getting alignment, getting buy-in. And so this AI agent handbook is a really simple, powerful, and visual way to share your vision and show, your teams how and where to start. So this handbook has 10 practical hacks to use AI agents for your business. It isn't just a recap of what we discussed. It really is a strategic asset that we would love for you all to explore. So we've got another link or QR code for you guys to scan, and we'll share this in our follow-up materials. It is also on our main landing page in the resources section. So check it out. Last but not least, we are always happy to share that we have a dedicated Discord channel for this community. So you and your teams can continue the conversation with fellow attendees, peers, enthusiasts. So join us. Scan that QR code, use the link, join the community. We've got Google experts on there as well. We're here to answer questions, and it's really there for you all to connect and stay connected before and after class. Last but not least, all that's left is for me to remind you of our next session, which will be Thursday, June 12th at the same time. This one will be focused on architecting intelligent agents. So how do you really build the foundation for success? You can add it to your calendar. It will be packed full of practical tips and strategic tips from our AI experts, Abraham and Luis, who are absolutely fabulous. Don't miss this one. Again, thank you all for joining today. We hope to see you all back on Thursday. Thank you so much. Have a great day.